well, welcome guys. We're going to be talking about time series analysis. Javier, he kind of filled you in on some of the stuff I do. I'm going to give you a little bit more background. Also, I'm going to ask you a few questions just to get kind of things kick-started so I can see what kind of demographic we have in the audience. Would you guys say, are most of you more like seasoned R users or kind of new on the newer end? If you can put like seasoned or newer in the chat, that would be cool, just so I can get kind of a heads up. Newer, seasoned, okay. All right, and forgive me because I ask a lot of questions and I do this to like, number one, to gauge the audience, but also to, it also gets me more fired up if you guys talk in the chat too. I hate jumping on these Zoom calls and just talking. So I like to get some personal feedback. All right, so I'm seeing half seasoned, half newer, which is good because perfect for everybody. I'm going to give you guys, whether you're newer or seasoned, I'm going to give you guys something that you're going to be able to take away from today. All right, with that said, I'll get started with the agenda. All right, first thing I'm going to go through, why listen to me today? Next thing I'm going to do, I'm going to cover the tools, Modeltime and timetk. And specifically because I thought this was a 2-hour presentation, I put 400 lines of code here today. We don't have to go 2 hours though. I saw that block off. I got kind of scared. I'll be honest with you guys. I got a little bit frightened. So I felt like I had to give you guys something extra today. I hope that's okay. We're going to go through a conclusion. I'm going to show you guys how you can save a company of over $1 million using these tools. And I'm also going to give you guys a free gift today. So that free gift, normally I give this away at the end of the training, but today I'm going to do it at the beginning because, well, I just want you guys to have it. This is the ultimate R cheat sheet. What it does is it consolidates the R ecosystem of 20,000 R packages into the 100 best. It saves you years of experience of trying to figure out what to focus on. So for the newer guys, this is going to be perfect for you. It's going to break learning R packages down by category. So if you want to work in these fields like text analysis, deployment, big data, machine learning, finance, and time series, when you want to work in these fields, these are the packages you need to learn. I'm going to drop it in the chat right now. Copy the link address, put this into the chat. And if you guys are okay with it, I do want to show you, because it has the model time stuff, rather than like dropping links every 12 seconds, which is what will end up happening if I don't give you this cheat sheet. I'm just going to enter my email in here, science.io. I want the cheat sheet. Okay, continue. And it opens right up. Okay, so this is the cheat sheet. It has 3 pages. Basically, all of these links are links to documentation. So this is like what I was saying. It helps you kind of figure out where to go. I'm going to focus actually on the 3rd page. So the first page is like the general tidyverse. Second page is called quote unquote the shiny verse. But what we're focusing on today is going to be this 3rd page, and specifically under the time series analysis. So this has like all of your special topics. So if you want to work in like text analysis, machine learning, geospatial, these are all of the packages that you want to learn. We're going to be focusing on timetk, time series analysis, and forecasting, model time. There are a bunch of other packages that we'll be loosely talking about, but I'm mainly going to be focusing on the core packages today. But I am going to show you some cutting edge stuff. Okay, so you guys all have that. All right, a little bit of background about myself. My name is Matt. Nice to meet you. I used to suck at time series, but nowadays I'm actually pretty good at it. And you probably don't believe me, so I want to prove this to you. Here's my team. As of 2 Fridays ago, we were in the number 3 spot out of 800 teams that are competing for this thing called the M6 competition. Don't worry if you've never heard of what that is. It's basically the biggest financial forecasting competition where they're rating people. These teams are being pitted against each other, and it's whoever can best forecast stock data. So we were 3rd. We're now, I think, around like 30th out of 800, but that's still pretty good. We're top 5%, and we're looking to get back up to 1st. We want to get into 1st. So before we were slaying competition like Sub-Zero and Mortal Kombat, I was lost in time series. So a little bit of background about myself. Time series, surprise, surprise, it's tough to learn. I used to do a lot of research, independent research, when I was trying to figure out how to do this stuff. And I'd see charts like these, and I'd read lots of reports, and nothing made sense. And as you can see, this workflow, while it is amazing, this workflow is just in how to pick out an error metric, depending on what type of forecast you're doing, if it has outliers, if it's season, if it has stationarity to it or non-stationary, blah, blah, blah. So as you can imagine, time series was tough for me to learn. It took a long time, but eventually I did learn time series. Why did I put so much effort into it? Well, here's my time series story. See, I used to be working at a company called Bonnie Forge. What we did was we manufactured, we'll just say industrial equipment. It was valves and fittings that went into oil applications primarily. We had a big problem while I was working there. So this yellow kind of area on this chart here, that is my time at Bonnie Forge. And this is what happened. Things were going swimmingly until in 2014, oil reached about $100 a barrel. Everyone was producing it. And then all of a sudden, the oil prices just dropped to about $25 a barrel by the end of the beginning of 2016. All right. So that's an issue for a company that relies on servicing the oil sector. So this led to record layoffs, lower workloads, and even lower revenue. That's when I decided to take things into my own hands. What I did was I reverse engineered what Kaggle winners were doing. So in 2014, at that same time that oil prices were dropping, there was a time series competition that was sponsored by this company, Walmart. Maybe you've heard of them. You might shop there. It's a big company. Obviously, they have a lot of products out there all over the United States and even globally. So they are very focused on forecasting, and that's why they ran this competition. I learned a lot from this because Kaggle is one of these really cool websites where people actually post some of the things that they're doing. And when the competition is over, some of the winners will post their solutions. So while this was happening, let me remind you, in 2014 to 2016, it was the worst period in our company's history. My department, small department, went from making around $3 million a year to approximately $15 million a year in that same time frame. This is a 5x increase. So what happened next? Well, by the end of 2016, I was reporting directly to the CEO. I got promoted, actually a couple promotions. I was making over $150,000 per year, and it enabled me to do this, which is really cool. So I got some other opportunities as I started to develop a little bit of our software, and actually add an extra 100,000 in my pocket per year by training elite teams. One of those that I work very closely with is S&P Global Market Intelligence. This is me over in London in 2019. They invited me to train, and this was, I think, the second training that year that I did with them. So had a lot of cool stuff, a lot of nice opportunities. I got paid to travel, I got paid to train and learn, which were my real passions. And you can see me and my daughter. I don't know if you guys have ever seen this book here, Applied Predictive Modeling by Max Kuhn. Max Kuhn is one of my idols, and I consider this the Bible. So if you guys need a book recommendation out of this, this is it right here. Applied Predictive Modeling. I call it APM. It's by Max Kuhn. Really good. All right. That was a little bit about me, but today's training is actually about you. So my goal today is to teach you a couple of skills that can save your company over $1 million per year. Okay. Fairly straightforward. Does that sound fair to you guys? Are you guys good with that? If that's okay, just let me know in the chat, yes or no. You guys all right with that?
No, I'm not okay with that.
I think I deserve.
Yeah, I deserve way more than
I can stop. Is 1 million not good enough? Because we can shoot for 2 in this training.
Nah, let's shoot for like at least like 5 mil.
Okay, I was gonna say I actually have a testimonial where I saved, where one of my students saved their company.
Just mute your screen, please. Yeah, mute your screen, please.
What's that?
I said to mute your screen, please.
Mute my screen. Okay. All right. Well, Jules saying 1 million is good, so I'm going to go forward, but I can always stop anytime you guys want. All right. Who wants to learn this skill? We've already kind of established that. This is where we talk about time series analysis and why it is so important. So we're going to be focusing on 2 packages, Modeltime and timetk. All right. So here are some of the packages Javier briefly had mentioned. This is actually has evolved into a full ecosystem of packages. So there's things like timetk, Modeltime Gluon, which is for deep learning, Modeltime H2O, which has automatic machine learning, Modeltime Ensemble, which is for Ensemble models, and Resample, which is for backtesting. We're going to focus on these two here today. Okay, so this ecosystem has gotten massive and it's really powerful, but even in 2 hours, if I went that long, we still wouldn't be able to cover all of it. So we're going to focus on kind of the core aspects here, but I've got some cutting edge stuff that I'm going to show you guys.
What camera are you using? Like,
oh, can you guys not see my screen?
No. Like,
Oh,
what? Like,
we can
what
hear
type
you.
of camera? Yeah, we could hear you. It's just like I'm curious. Like, your camera's like, it looks good quality.
Oh,
like,
okay. Yeah, it's a Canon. It's a DSLR. Yeah, so it's like a $3,000 camera. It was recommended to me by a buddy who does courses too. So I just I've been upgrading everything. You see the background back there? We got the business science logo. I'm pretty pumped about that one too. So yeah, I've been dropping money like crazy on this thing.
Daddy's rich type shit? Question mark.
What's that?
Is Daddy rich?
Is Daddy rich?
Yeah, like, is he rich?
No, my father is actually, he makes a lot less money than I do.
Yeah.
All
hey,
right.
And just quick second, Matt. Yeah, I'm gonna go ahead and mute everyone, and let's just pause all questions here until the end for Matt.
Yeah, that sounds like a good idea.
Yeah, and feel free to ask questions in the chat. I'll try and answer them as we go along.
All right, sounds good. All right, guys. There's 3 phases of the game here that I'm going to cover with you guys. All right. So we've got the first part is just the timetk essentials. And what we're going to be doing is focusing on visualization here. So this is a really important aspect. And actually, I'm going to show you kind of a new hack that I just recently started doing with time series visualizations. Okay, guys. So first things first, we're going to load in just a couple of different libraries. And I'm going to pull in some sales data here. This is from that Walmart 2014 competition. And we have just a kind of a subset of that data. So we're going to be looking at the store ID.
Wait, you said you work for Walmart? Sorry, I couldn't like really understand you.
So I don't work for Walmart, but this data is actual data from that 2014 Walmart competition that I was talking about. So,
okay.
Yep. Good question. All right, so sales data. We have some sales data in here. What I'm going to first do is show you guys how to do some quick kind of visualizations. All right. So what I'm going to do is just take the data. I'm going to select the ID, date, and weekly sales figures. And I'm just going to show you guys how to do this, the most basic thing, which is just visualize. So we're going to first group by ID, and you can see I've got groups. And what this plot time series function is going to do is we're going to be able to then see all of the different time series. So each of these series, what they are is something that we're going to want to forecast. Like if we were working
according to my calculation, are we allowed to like get comfortable for the meeting type shit? Like, can we get comfortable for the meeting? Like take off our clothes type shit?
All right, thank you. Yeah, that guy was getting a little.
I booted him. I'm sorry about that.
Okay, no problem. So anywho, all right, this is what we're trying to forecast, guys. Let me break it down. We've got several different IDs, and what this is actually one of the different departments within a store. So the first one here would be an actual store, and then the second one would be like one of the departments. It's a weekly time series, so each one of these data points that you see me hovering over is actually 1 week out of the year that store is making, for this particular department is, you can see that there's kind of like some different trends and patterns that are going on in there. So what we're going to try and do is we're going to try and forecast these today. But first things, before we can do any forecasting, we got to visualize it. So the first function I want to point to is this plot time series. The next thing that we can do is we can start to kind of analyze some of the features that are in our data and see which ones might have some sort of predictive ability. We can use a different plotting function called plot time series regression. And the cool thing is once you get the hang of plot time series, this function is not a whole lot different. You just basically take your same sales data, group it by ID. Now I didn't subset, I didn't do the select here because I wanted to leave some of these other features in here. I just want to give you guys an example of what you can do. So if you add engineered features in here, you can apply a formula and do like weekly sales as a function of is holiday, temperature, fuel price, which might be predictive of your sales numbers. So what's cool here is if we do that, you can see kind of the model that would be fit through a linear regression. And some of these are better than others. So you can see that some of these features probably would be pretty good. And we also get a summary here of each of the different, based on like each of these different groups that we have in our data set. So the first one here, I'll just kind of briefly take a quick look at it. 1_1, which is the first department within that store. And we can see temperature looks like it's a pretty high predictor if we wanted to use temperature. And we can see that we have an R-squared of about 0.20. So, you know, we'll say 20% variance explained. Okay. So this is just another good way where you can visually start to see which of these time series kind of you can develop predictors out of. Okay. And then the third thing is what I recently started doing was kind of taking it to the next level. I don't know if you guys have ever heard of Telescope.js, but this is a really cool enhancement that I started to kind of add on. So this is a plotly plot. But if you take that plot time series function that you learned about up here and just add another argument, interactive equals false, what this does is it makes a ggplot. So this is actually a static ggplot. And then if you add this facet trelliscope and you give it the faceting as the ID here, and then I'm going to do as plotly equals true. What this does is it helps with bigger data sets. So this is pretty cool. Should run through it pretty quickly. This is Telescope.js. What you can do is you can adjust your grid here, and you can add all of your time series on one grid if you only had 7. But if you had, like, say, lots of time series, more than 7, using kind of just the plot time series approach might be a little problematic. So if you have many, this is good because you can see up here, you can do the next, and you can quickly get to the last, and you can actually do filters and stuff in here. So pretty cool. It's a nice little hack I wanted to show. I'm going to be using it actually a lot in this training. And then the next thing we can do the same thing with all of the plotting functions. So there's probably, I want to say 7 or 8 time series plotting functions. And I'm just showing you kind of 2 examples. Plot time series is the one that I use most, but we'll just go with the plot time series regression again. And I want to show you how you can use that with the Telescope.js. So you remember that previous plot where I had plotted out a bunch of these kind of like regression summaries for each of these time series. Well, you can see now I've got all of them in Telescope. Okay, so pretty cool. All right, so that is plotting. So now that you know a little bit more about visualization, we can start to move on to modeling. Now, the first thing I'm going to show you guys in this training is kind of, I call it the new old way. So the old way is like using tools like ARIMA and Profit and running time series through loops. So if you remember, we've got 7 of these time series, right? So if I do this, you can see we've got 7 different time series here. Let me switch that 4 and 3 and make that. It's still looking a little weird. Anyhow, so there's 7 different time series here. So what we would do is we would run through each one of these in a loop, and we would use, so if we have like three different models, we'd apply 3 models to the first one, 3 models to the second one, 3 models, and so on until we get to the last one. And then we would decide which of those models are the best for each of the time series and use those for our forecast. So I'm going to show you how to do that. I call it the new old way because I actually implemented this after I implemented this final global modeling. So we're going to talk about global modeling at the end, and global modeling is, in my opinion, the way to go, especially if you work at Walmart. So here's how to do the iterative modeling, or what's called model time nested. You can just follow this format. So I'm going to load these packages here, tidy models. If you guys have never heard of tidy models, that is kind of like the premier machine learning. It's kind of like scikit-learn, but in Python, right? So Modeltime takes tidyModels package and converts it into a forecasting framework. timetk is more for like time series visualizations and data wrangling. Tidyverse for working with just our core tidyverse packages like dplyr, ggplot2, and so on. And NANIR, I can never pronounce this package. It's basically for working with missing data though. All right, so I'm going to read in our sales data again. And then what I'm going to do is what's called extending the data set. So I'm going to take the sales data, which looks something like this. I'm just going to grab the ID, the date, and the weekly sales. So we're just going to do a univariate analysis here. So we aren't pulling in any of the holiday features or anything like that. Yeah, I see in the chat, it's like Nannier. Yeah, there we go. So Nannier is for missing data. And we're going to see an example of that here in a second. So I just renamed these columns, ID, date, and value. This is something I always do. It's just kind of like a pet peeve of me. I usually have an ID column for which time series that belongs to, the date column, and then the value. And then we're going to do this kind of unique thing called extending the time series. So this is where we're going to extend it 52 weeks into the future, because that's going to be our forecast horizon. So all it's going to do is it's going to add a bunch of missing data at the end of each one of these time series. So each one of these 7 is going to get, and we'll see an example of that when I plot it. So I'm just using this extend time series, and now it goes from 1,000 to 1,365. Okay. Next thing I'm going to do, I'm going to use that plot time series function. I'm going to use it with this thing called geom miss point, because I want to show you guys the missing data. So let me run through this real quick. Okay, control enter here. This is the plot time series. You can see here there's a bunch of blank space here. Why is that? Well, that's because we're using the extended tibble, and I've added a bunch of NAs to it. So you can now see those NAs when I do this geom miss point. You can see them here. And we can also do the same thing with the Trelliscope.js if we want to examine these a little bit further. And we can actually like zoom in on these things and switch to them and kind of see specifically, these are all the missing values that were just added. Okay, so hopefully that makes sense. We just added a bunch of missing data to the front of each of these time series. Okay, all right. Now what I'm going to do is what's called the traditional. So this is the new old way. We're doing the traditional iterative approach, but it's with my model time nested forecasting. We're going to use 3 different model types: ARIMA, the classic traditional; Profit, the new traditional; and then XGBoost, machine learning. This is a slower method, but it can be more accurate than what I'm going to show you guys next. But we're going to see that it's a lot slower than what I'm about to show you. All right, so the first thing I want to do is I'm going to take this data extended and I'm going to put it into this nested format. So I'm going to use a nest time series function. And you can see that this data, which was 1,365, it's now been compressed into just the IDs. And you can see there's a tibble in here of actual data and future data. So our actual data is 104, our future data is 52. So all of that missing data, this missing portion here, got placed into the future data. And then I said the length of the actual is just going to be 2 years prior. So from here all the way back to about here is where it's going to be cut off at. Okay, so that's kind of what we call a look back period. And then we're going to add a length of the test data. So what I'm going to do here is we're going to take this actual data. So remember this portion here, and we're going to split it up. We're going to split it into a training and a test set. Okay, we're going to save that as nested data tibble, and that's all we're doing here. Okay, this is purely formatting, because once you get this process down, you can basically replicate it for any type of problem. So we just need to format it in this method. And then what we're going to do is we're going to loop through each of these IDs here, and we're going to run forecasts models on each one of these. So we're going to, here what we're going to do is run 3 different models. So the first one is ARIMA. And let me open this up. So ARIMA, each one of these models will take a recipe and a model. So the recipe is going to be developed first. It's fairly straightforward recipe. We're going to take, if we remember up here, we have value as a function of date. Now, ARIMA in the model time framework uses a function called ARIMA reg, and the format that we also always have to provide it as value and a date. All this extract nested training split does is it pulls out the first training set, just a 52 by 2. So it's basically looking in here and then taking the first 52 data points that was identified as a training split. And that's what we're going to develop what's called a recipe off of. So our recipe is just basic. It just says it's got one outcome, which is value, and one predictor, which is date. Okay. Once we do that, we can develop what's called a workflow. And then if you're familiar with the tidy models framework, which Modeltime leverages, we have to do two things. We have to add a model and a recipe. So when we do that, our model is going to be an ARIMA reg, which stands for ARIMA regression, with a seasonal period of 52. And then we're going to add the recipe, which tells it, which predictors in that data set.
Take care. Bye.
Okay. So once we have that, we've got our first recipe that's kind of ready to go, our first workflow. We want to do the same thing for profit. So we're going to do value as a function of date. It's the same recipe virtually. We're just calling it recipe profit now. And then we're going to do the same type of workflow, and we're just going to swap out ARIMA, which is what we had up here, with profit. And we're going to give it yearly seasonality. Okay. So when we do that, we now have one workflow for profit. And then we're going to do the same thing with XGBoost. The major difference here with XGBoost is XGBoost is a traditional machine learning model. So we have to do a little bit more with the recipe. So we're going to take value as a function of date. So this will look the same, but we can't use the date feature because it's a date time feature. And I'll show you what this kind of looks like. So if we gave our model this date column, it's gonna give us an error because it's a traditional machine learning model. So we're gonna do a trick. We're gonna create timestamp features using the step time series of this date feature, and it's gonna pull out things like year, month, day of the month, hour, minute, second, and it's going to make a bunch of different features for me. Okay. And then once we use that and extract out the important information of these timestamps, then we're going to remove that date feature. We're going to then remove all of the zero variance predictors. So if anything's a constant, it's going to drop it because XGBoost will complain. And then we're going to dummy any of the nominal features like day of the week. So if it's like Monday, Tuesday, Wednesday, we're going to convert those into dummy variables. So that's what this does. Okay. And here's an example. So remember, we just had value as a function of date. So remember, value as a function of date is only two features: our target value and our date column, which is the timestamp. But when we run it through this recipe, here's what it looks like. It ends up converting it into value as a function of date index numeric, like all these engineered features: date year ISO, date half, date quarter, etc., date week 2, date, some cyclic features, some month features, and so on. So you can see we now have 31 columns. So remember, it was value as a function of date. Now it's value as a function of all of these engineered features. Okay. Hopefully that makes sense. And that's what's going to allow us to really make this model work for us. So we're then going to create a workflow XGBoost. And now we have our 3 different modeling, we'll say like prototypes. And now we need to fit those 3 to the nested data structure. So we're going to move into the section 3. We're going to use this function called Modeltime nested fit. And what this does, and let me space this out a little bit so you can see what I'm doing. So I'm going to use this Modeltime nested fit. And we're going to take this nested data structure, which looks like this. So it's each of these Walmart IDs, remember each of the departments. Okay. And we're going to take the splits column and we're going to run each of these models on the training portion. And we're going to evaluate them on the testing portion. So we have 7 rows here times 3 models. So it's going to basically iteratively go through all of these. Okay. I'm just going to hit Control and Enter so you can see what it's doing. It's going through the first model right now. Went through the second, went through the third. And that is just for the first of 7. Now second of 7 IDs, and you can see it's going through. So it's basically a loop, right? Does that make sense, guys? Does that make sense to you guys?
Yeah.
Okay, cool. All right, so it's finishing up here, and we can see it took about 28 seconds. So this is why I say this is like the new old way. It's still taking forever, but this one-liner of code here basically saves you like 300 lines of code. So it's kind of like improving your ability to just kind of throw models at the problem and then experiment quickly. Okay. So next, what we're going to do is examine some key information. There weren't any errors. So this is commonly what I do. If you get an error, like you'll see like an X in one of these models, if you have an error, then you'll want to review the error report, but there was no error report for us. Then what you can do is you can extract the accuracy. So these are the accuracies of each of these. You can see that we have some missing values from R squared. That normally happens if the predictions are constant. So for ARIMA, that can happen quite often if you get just like a straight line prediction. And we'll see that here in a second. What we can do is also interactively group these and take a look at them. So this is what this table model time accuracy function. And what I can see here is if I sort by RMSE, and if I look at each one of these, I can see which one's the best. So usually the lowest RMSE is the winner. We can see XGBoost won the first one. We can see Profits winning the second one. ARIMA won the third one. Fourth one, XGBoost, and so on. Okay, cool. So now we can do, and what you'll commonly want to do is then also extract the test forecast. So we're going to pull out the test forecast. What I do is I group by the ID column, which is right here. We're going to group by that. And then we're going to do plot model time forecast. And we can see all of the forecasts on the test portion of the data set. And if we want, we can also use Trelliscope for that. And that just allows us to kind of examine things a little bit closer. So I'm doing Trelliscope right now, and we can like zoom in on our plotly plots. We can deselect them. So we can see here that ARIMA is just a straight line because it's not really getting the seasonality in there. Profits doing a little bit better job, but it seems like it's a little bit low on the first one. But XGBoost for this particular one seems like it's probably doing the best, but still not perfect. Okay. And you can do the same kind of process and go through all of your different time series here. Okay. All right. Next thing you want to do, now that you've got 3 models, you can select the best. Now, normally probably what you do is make many more models, and you probably hyperparameter tune too. We didn't do any of that. We kind of skip that process. So I'm going to do this thing called selecting the best based on RMSE, and then we can get the best model report. And then basically what it did was it just simply took a look at for each one of these groups. It just picked out the best RMSE. Okay, so if like for 1_1, that was this XGBoost model that did the best here. That was 907 for RMSE, and that's what it picked, 9017 for RMSE. Okay, and it just did that for all of them. Okay. All right, once we have the best models, we're then ready to refit. We refit against the entire data set. So we're going to take our best nested model time, which is the output from up here. And we're just going to, which looks like this. It's got all these model time tables. Now it's just 1 by 15 because there's only one model in the best model for each one of these. And then we're going to refit on the full data set. So all of this actual data is going to refit, and then it's going to try and predict the future, which remember, it was just missing values. So we're going to try and predict that now. All right, I'm going to run that. You can see it's, again, an iterative process, and you can see it's training different models. Some of them are XGBoost, sometimes they're ARIMA, and it just depends on which one was the best. All right, once you do that, we are ready to examine the future forecast. The last step is always, we want to extract out the future forecast, group it by ID, and then we want to visualize the plots. see what the future forecasts look like. And we can do it in Trellscope too, just to make it a little bit easier to see. And here we go. So we can see this is the XGBoost model. It's 3 XGBoost. This is the XGBoost model was the best on this one, and that's the future forecast. This is the profit model. This is the XGBoost. The ARIMA model was the best in this, but look, it's just kind of a straight line. XGBoost and so on. Okay. All right. So conclusions. We got some pros here. This streamlines. One thing I failed to mention is normally when I used to do this, like back at Bonnie Forge, this would be like 2,000 lines of code minimum to be able to accomplish everything I just showed you. Notice here, what do I see? It's 137. That's a lot less than 2,000 lines of code. So that's definitely a clear pro. But the con is it was still 15 seconds to fit 3 models times 7 time series. Actually, it was 27, but that's probably because I have Zoom running. So the key here is when you get into like Walmart's problem, which is where you're going to save millions of dollars, they have thousands and thousands of time series. So if we just think about like what we saw, say it took us 15 seconds to run this script, which it took 24 seconds or 27 seconds because I have Zoom running. Well, if we scale that up to 7,000 time series, that means it's 15,000 seconds, which means 4.2 hours. And I can tell you this, Walmart has a heck of a lot more SKUs than just 7,000. They have probably around 7 billion. I'll tell you why they have that number. All right, so what can we do? Well, what we can do is we can do a different approach. And this is the third component that I wanted to show you guys today. All right, so we're going to follow kind of the same process, but this is what's called global modeling. So this is all the same through pulling in the sales data. We're again extending it, which is just adding those missing values to the end of it. And then we can visualize that again with the facet Trellscope. Again, this is all the same code that we saw in this file here. We just have some missing data now that's been added to each one of these time series. Now is here where it gets a little bit different. So what we're going to do is we're going to take our data extended. So has this full data set here, which contains both our actual data and our extensions. And we're going to grab out, so our data extended is 1365. We're going to split it out. We're going to just grab the data that is the actual data, and we're going to say that as data prepared. So this is my actual data. And it's basically the data without the extensions. And then the future data is going to be where there is missing value in the value column. So that's going to be this data set here, which all has missing values. So we're basically grabbing out for each one of these time series, all of that missing data. And that's what we're going to use. And we're going to model it all at once. That's why it's called a global model. So what we're going to do, so we've got data prepared, data future. We're going to primarily be focusing on this data prepared. And we're going to save this data feature until we do our future forecast down here at the refitting stage. Okay. We're going to take our splits. What we're doing is taking our data prepared and we're assessing 52 weeks into the future. So this 52-week here period, the last 52 week of that time series. Okay. So that's going to give us some splits here. And we're going to see 637 by 364. So we have 364 timestamps in our test data set, 637 in our training data set of a total of 1001. So 1001 is right up here in our data prepared. So it's just basically splitting this into a training and test set globally, all time series at once. Okay. Once we do that, we can take a look at developing and getting into our machine learning. We're just going to make one recipe and we're going to reuse this recipe. You can do more recipes, but for machine learning, the nice part is these global models like XGBoost, support vector machine, random forest, and so on. Generally speaking, you can get by with kind of like a standard process. What we're going to do is do value as a function of dot. So it's going to be value as a function of, I think, just the date. Oh, date and ID. Okay. what we're going to do is, and this ID feature becomes important here because we're doing a global model and it has to be able to see which ID of a time series that we're going to be predicting. Okay. So that's why we're doing value as a function of dot, as opposed to just value as a function of date, because we're not going to be looping through anything. This time, what we're going to be doing is forecasting all of these time series at once with one model. All right. It's kind of a weird concept, so it kind of throws some of my students sometimes. This kind of process you can kind of use as maybe like what I would call a boilerplate. So we're going to drop any of the levels of ID. So if there's any extra levels, we're going to get rid of them. We're going to then add the time series signature on the date feature. And notice we have an outcome and a predictor of 2 right now. We're going to drop the date feature. We're going to, or excuse me, do the time series signature and then drop the date feature. And then we're going to zero variance all the predictors, and we're going to dummy all of the categorical or what's called nominal predictors. All right. So when we do that, we get something that looks like this. Pretty crazy, right? We now have 38 features here. It looks very similar to what we did with the XGBoost model when we did the nested forecasting. But the main difference here is we now have IDs in here as well that machine learning model is going to see. Okay. Then once we do that, we're ready to start modeling. So we're going to do very similar. We're going to create a workflow. We're going to add a model. So remember, a workflow takes a model and a recipe. The only difference here is we're going to fit each one of these. So we're going to basically run the entire model first. And what this is going to do is actually train a boosted tree with this recipe, okay, on the training splits. All right. We can do the same process for a support vector machine. We're just adding a model here. Again, this is a little bit simplified because we aren't doing a whole lot of hyperparameter tuning and that sort of thing. But now we have a second model here. And here's the beauty. Remember how it took like 25 seconds to train those models? It took less than probably a quarter second. It took, actually, I think it does keep track of how long it took to fit. And I want to say, why isn't it shown here? Yeah, I'm not seeing it, but it was fast. It was fast. So next, what we can do once we have these models fit. So again, we're like at a quarter second for 7 time series. And the thing is, the difference between 7 and 7,000 isn't like, 1,000 times a quarter second. It's more like 2 minutes. So it's fast. So it's more scalable. All right. So what we can do then is take a model time table. All we're doing here with this model time table is kind of organizing these models for us. And once we do that, we're ready to start kind of this model time workflow. So we're going to first do this thing called calibration, and we calibrate on the testing set. And that's going to add these columns here. So we're basically taking these models that we've made and we're calibrating them on the testing data set of the splits. That's what this testing splits is. Okay. Once we have that calibration table, we're ready to move on to evaluating the test accuracy. So right here is the accuracy. We're going to run calibration table through this thing called model time accuracy. We're going to tell it to do accuracy by ID because that's going to be important. We want to actually pick out which model to use by each ID. Even though these are a global model, we can tell it which model to use if one model tends to do better on a certain Walmart department. So
Hey,
we're
Matt,
going to do
just a quick time check. We've got about 5 to 10 minutes left.
All right, cool. All right. So yeah, basically we've got the accuracy table here. We will do the accuracy. We can again put this into a table that looks like this. We can see that for the most part, the XGBoost is going to be the clear winner here with the lowest RMSE. We can grab our best models, which looks something like this. And this is just going to allow me to grab the lowest RMSE. And when we go to do our refitting down here, that'll come into play. we can also visualize the test forecast. Okay. All right, so we're visualizing the test forecast. This green model doesn't seem to be doing too well, but this XGBoost model, at least on this first time series, looks pretty darn good. The XGBoost model looks pretty good right here too. So again, seeing a big benefit here of this new global approach to forecasting. It was faster and we're getting halfway decent results. Okay, once you are finished with that step, we do refitting. We fit it on the full data prepared. So we take our calibration table, looks something like this with our models in here. We're gonna retrain it all on the full data set. That's gonna be called our refitted table. And then we do that, and then we just make our future forecast. I won't go through all the code here just because we're running short on time, but we're going to see some pretty impressive results here. All right, cool. So when we now have the global model, best model, and it's the XGBoost was the clear winner here, and we can see that we're getting a massive benefit here because these forecasts all look very good. And they actually have, and they're much faster. So basically, that's pretty much the end here. I'll just go through quickly. Here's how you can save a company like Walmart. So what does a 1% improvement over ARIMA mean? Well, we're probably doing, not only are we beating them on speed now, but we're also beating ARIMA in accuracy as well. Because remember, all those ARIMAs were just like a straight line. So you can save a company like Walmart hundreds of millions of dollars with just a 1% improvement. And with model time, you can probably get, I would say, at least 5 to 10 to 15% is what I was seeing when I was starting to experiment with some of these machine learning approaches back in the day. So you can easily see, hopefully guys, you can easily see why companies are willing to spend a lot of money on people who are really good at forecasting. You can see data science. Once I started learning it, 2x my salary, went from 75K to 150K a year. So my question to you guys, who's inspired to start getting better at forecasts? Hopefully what you guys take away from here is that forecasting is, we've got some pretty impressive tools in R. The inspiration for today was the M6 competition. Remember the tools that we use, and I can't give you the exact strategies, but that's pretty much something similar to that may or may not be what we're using for the M6 competition. So if you want to dominate whether it's competitions or if you want to dominate, basically stand out from your peers at companies like Walmart and whatever other company, timetk and Modeltime, that's where it's at. We're also, what we aren't using is ARIMA. So if you're smart, this is my motto, abandon ARIMA. I've done a lot of analysis, and ARIMA tends to be better for like quarterly and monthly data, but like it pales in comparison to some of these newer approaches. And when I did the analysis of the past like 10 years of competitions, time series competitions, ARIMA wasn't in a single one of the winning solutions. So I'm saying abandon ARIMA, even though that's pretty much what every college out there is teaching you. Here's a secret. It's not what's winning the competitions. If you want to do high performance forecasting, learn Modeltime. All right. I do have a special offer for you guys. If you guys want to learn, I'm just going to kind of fly through these slides because I don't really have time, but we have this new thing called a time series gold package. And what it does is it teaches you all of this stuff here that I'm flying through. Outliers, imputation, how to work with X-regs, all the stuff that I didn't have time to show you guys in here. And it goes through a much slower process. So you may be feeling a little overwhelmed right now. I have a training that has literally 40 hours, and that's just the time series course. Also, it covers how to scale this up to thousands of forecasts, how to use deep learning, how to use deep learning and machine learning. And it's got quite the value. You get a certificate of completion, let's see, you get a we have a special offer going on called the Gold Package, where you're also getting a business problem solving course as well, which is the secret to connecting data science to business. And it's also a secret of technical interviews. And we have 2 portfolio project data sets that'll help you apply what you learn in the time series course as you're going through to a separate data set, actually 2 separate data sets to test your skills and also develop portfolio projects when you're getting ready to apply to your Walmarts, Apples, Googles, wherever. Data set 1 is a stock data set. Data set 2 is an energy source data set. We're going to give you 2 Shiny apps too. Actually, this is just real quick. I know we're running late on time. These 2 Shiny apps that we give you are actually ones that I got paid $15,000. Well, they're based on ones that I got paid $15,000 for the first and $10,000 for the second one. So $25,000 value. One is this hierarchical time series forecaster, which helps you be able to visualize time series hierarchies, which is also very important for companies like Walmart. And then another one is a different problem, totally unrelated to forecasting, but also a very big problem is customer churn risk. So if you've ever dealt with Shiny, this gives you 2 apps that you can dissect. You get a time series cheat sheet that walks you through that whole process that I showed you. And let's see. Oh, and you get a double your money back guarantee, because basically if you aren't satisfied with this course, I'm not confident that I'm going to actually pay you to take somebody else's course. You know, I know you're going to love it. I basically, you know, this is this is the best time series course on the planet. So you're going to love it. I have a double your money back guarantee. Gets amazing results, like 20% raises, completed 2 technical interviews for time series forecasting, got 2 competing job offers, and landed a lead data scientist position. So we're going to do first 15 people get it for $5.99. I'll put the link in the chat. Let's do this. Copy the link address, paste it here.